Subtopic 6.4, magnetic force on a moving charge. So before this, we have learned about magnetic field and also magnetic flux. What about magnetic force? Magnetic force exists when there is a magnetic field. And for magnetic force, it can occur to a moving charge, either it's proton or electron, to a single wire and also two parallel wire. Okay, so for this subtopic, we are going to focus on magnetic force on a moving charge. So in chapter 5, we have learned about electric force. So how does electric force exist? It is due to a charge that produces electric field in the space around it, or we can call it as point charge. And then we also need a second charge that responds to this field, or we can say that this is the test charge. If we have point charge only, it only produces electric field, but there will be no electric force. But when we put a test charge, baru akan ada electric force. It's either attract or repel. What about magnetic force? Okay, it's almost the same concept. To produce magnetic force, we need a moving charge or electric current that will produce magnetic field around it. Then we need another second current or second moving charge to respond to this magnetic field. Then baru dia akan produce magnetic force. So untuk this subtopic, you need to focus to the moving charge, proton or electron that moves in a magnetic field area. We want to see what is the magnetic force that exerts on that proton or electron. When we have a test charge, let's say proton or electron, moves with a velocity, enters a magnetic field strength B, it will experience a magnetic force. Okay, so how to determine the direction of magnetic force? We will use a hand rule. And how to determine the value or the magnitude of the magnetic force? We will use this equation. F equal to QVB. Actually kat sini ada sin theta. So magnetic force on that moving charge is equal to Q, the magnitude of the charge, V, velocity of the charge, B, the magnetic field strength, and sin theta. Theta is the angle between V and B. For example, we have a proton. This proton moves in an area of magnetic field to this direction. At the same time, other magnetic field to this direction. So there will be magnetic force exerted on this proton. So it depends on the rules that we are going to use. Some other, it will directed upward or downward. Okay, but the most important thing that you need to know, the magnetic force is proportional to the V and also B. Okay, we have the direction of V and B. Force, magnetic force always perpendicular to the V and B. So this is the equation for magnetic force on a moving charge. You can only use this equation when there is moving charge because we need to use Q. Okay, so angle theta is the angle between V and B. Direction of F always perpendicular to the plane of V and B based on the diagram just now. And you can determine the direction of F by using hand rule. Before we go to the hand rule, from this equation, you can also find the value of magnetic field strength. Okay, why? Because there is B in this equation, so you can just rearrange it and use it to find the magnetic field strength. So kalau sebelum ni kita ada equation untuk magnetic flux, BA cos theta. So you can also use this equation to find magnetic field strength if you have the value of magnetic flux. But if you have the value of magnetic force of a moving charge, then you can use this equation to find B. So there are three methods to determine the magnetic force on a moving charge. The first method is by using Fleming's right hand rule. What you need to do is try to do your fingers like this. Okay, your thumb 90 degrees with your index finger, and your index finger 90 degrees with your middle finger. Your middle finger is also 90 degrees with your thumb. all are 90 degrees with each other. Bukan macam ini ya. It must be like this. Okay, make sure you try to do it. And then the symbol for your thumb will be the direction of F, magnetic force. Your index finger will be the direction of velocity of the moving charge. And your middle finger will be the direction of magnetic field strength. Okay, if you use your right hand, then it refers to the proton or positive charge. But if you use electron or negative charge, we can use our left hand. Thumb will be your F, index finger will be your V, and middle finger will be your direction of B. F always perpendicular or 90 degrees with V and B. But V and B boleh ada angle between them. For method 1, if we have proton or positive charge, then we can use our right hand rule. Okay, so your thumb will be F, magnetic force. Your index finger will be the direction of V, velocity of the moving charge. Your middle finger will be the direction of magnetic field strength. Okay, so make sure they are 90 degrees to each other. So for negative charge or electron, we can use our left hand rule, F, V, B. Sama sahaja, cuma pakai tangan kiri. Method 2, we use palm, our tapak tangan. So how to use the palm? You need to do it like this. Make sure your thumb is 90 degrees with the rest of your fingers. Okay, and then the thumb will show the direction of V, velocity of the moving charge. The 4 fingers right here will show the direction of B, magnetic field strength, and the normal to your palm. Okay, you can put a pen or pencil on your palm, directed 90 degrees with your palm, macam ni. So this will show the direction of F. If we have a proton, we use right hand. But if we have electron, then we can use palm on our left hand. So if there is angle between V and B, you can adjust your hand according to the angle. Ada possibility ada angle between V and B. Okay, maybe the 50 degrees, 70 degrees or 10 degrees, but the direction of F always perpendicular to it. Okay, for method 3, dia terbalik dengan method 1. If we have a proton or positive charge, then we need to use left hand. Bezanya adalah the symbol F, B, V. Kalau method 1, F, V, B. Kalau method 3, F, B, V. So it depends on the method that you want to use. If you choose to use method 1, remember that it is F, V, B. But if you want to use method 3, F, B, V. Okay, so maybe you can choose which method that you are comfortable with, so that nanti you tak confused lah dengan method lain. If you are not sure nak pakai tangan kanan ke nak pakai tangan kiri, don't worry. You can use only one hand. Okay, for example, if you choose to use method 1, F, V, B, okay, right hand adalah untuk proton. Okay, so you can use your right hand. But if we are given electron or negative charge, still kita boleh pakai right hand juga, but just opposite kan direction of force. For example, kalau kita pakai proton for method 1, the direction for positive charge is upward. Tapi kalau kita tukar dengan negative charge, kita just terbalikkan je. Arah F will be downward. Okay, so tak ada masalah kalau you nak pakai satu tangan sahaja, but choose your own method. Okay, kalau you nak pakai method 1, stick to it. Okay, jangan pakai banyak method, nanti you confuse. Okay, for example 6.2, determine the direction of the force. Okay, for question A, we are given proton or positive charge. Okay, what you need to do is choose your own method, method 1, method 2 or method 3, and then try to follow the direction of V and B given in the equation. Okay, ikutlah. Contohnya method 1, F, V, B. Saya pakai tangan kanan, positive charge. So ikut arah V ke kanan, B ke bawah. So tengok arah F ke mana. If we refer to the screen that we are looking right now, okay, saya akan buat macam ni. So the direction of F will be into the screen. Okay, you can try to do it also. If you want to use method 2, palm, okay, So you boleh pakai you punya right hand palm and then buat macam ni lah. V ke kanan, B ke bawah. So F will be into the screen. If you do it on your books, okay, you ikutlah buku awak tu. V ke kanan, B ke bawah. So F will be into the page. Method 3, kalau positif guna tangan kiri, F, B, V. So V ke kanan, B ke bawah, F will be into the page ataupun into the screen. B and B ni 90 degree, so F ini bukannya ke atas kanan, tak, dia sebenarnya into the page. Sebab susah nak tunjuk secara 3 dimension kan. Or if I use a XYZ axis, X, Y, Z. Okay, so B will be directed downward. V directed on the positive x-axis. So F will be directed to this direction. Okay, sebab yang ni mungkin you akan confuse lah. You akan nampak macam F ni ke atas. Tapi sebenarnya dia ke belakang ataupun into the page. Or in this Z direction. Okay, question B. For this question, dia sebenarnya B is directed upward on y-axis. V is directed on z-axis 90 degrees. Okay, so try to use your hand rule ataupun palm rule. Try to determine the direction of force. Remember that this is negative charge or electron. Okay, kalau method 1, FVB, saya pakai tangan kiri. So V is into the screen or into the page, B is upward, then we'll get the direction of F to the right. Okay, ataupun nak pakai tangan kanan juga. Contohnya, saya nak pakai method 1 tapi saya nak pakai tangan kanan juga walaupun dia adalah negative charge. So saya buat juga FVB, V into the screen ataupun into the page, B ke atas. Saya akan dapat force saya ke kanan. Okay, tapi sebenarnya sebab ini adalah negative charge, kita terbalikkan. Arah dia bukan ke kanan tapi ke kiri. If we use palm rule, kalau negatif kita kena pakai left hand. Tapi boleh je saya nak pakai right hand, cuma saya terbalikkan je arah force tersebut. Kalau saya dapat arah force ke kanan, terbalikkan dapatlah ke kiri. So the direction of magnetic force for question B will be to the left. Okay, for question C, we can see that there is negative charge or electron that moves downward, okay, based on the direction of V. What is X right here? X is the direction of B. X ni maksudnya into the page ataupun kalau kita tengok screen, into the screen. So, use your hand rule, follow the direction of V and B and then determine the direction of magnetic force. Okay, so the answer for question C is the magnetic force will be directed to the left. Next, for question D, we have a conducting wire or a wire that has current in it, and then this negative charge or electron that moves downward. So where is the direction of magnetic field? Okay, so as we know that when there is a current, there will be magnetic field around it. So kena pakai hand rule, right hand rule, untuk you tentukan arah magnetic field on this wire. So since the direction of current is to the left, so the magnetic field around this wire will be, dia akan macam ni lah. Okay, dia akan rotate macam ni. And then when we have determined the direction of magnetic field, we know that the magnetic field will be keluar daripada this screen and then it will goes into this one. Dia macam seolah-olah keluar daripada page ataupun screen and then masuk pusing kat sekeliling wire ini. So this moving charge is situated dekat bahagian atas ni, di mana magnetic field strength at this area is into the page. So by using your hand rule, okay, by using your method that you choose, try to determine the direction of F, magnetic force, on this moving charge. So V ke bawah, magnetic field dekat kawasan ni into the slide, into the screen or into the page. Then F will be directed to the left. Next, for question E, the direction of current is upward on this wire. So by using our right hand rule, okay, current ke atas, we will know that the direction of magnetic field strength around this wire is like this. Okay, so maksudnya dekat belah sini, the magnetic field strength is out of the page, and at this part, the magnetic field is into the page. So there is proton right here, which is moved to the right. So use your method to determine the direction of magnetic force. V ke kanan, B is into the page. Where will be the direction of F? So F will be directed upwards. Apa kesan magnetic force ni? It will pull the moving charge to its direction according to the direction of magnetic force. Okay, if you have problem with this example, maybe dah try gunakan your own method tapi still tak dapat, don't worry, just share with me dekat dalam Telegram and I will help you to understand this example. It's very important sebab ini adalah basic asas. So you need to choose which method that you want to use. Make sure you understand the method that apply in this kind of example. Okay, next example. A proton moves at 3 times 10 to the power of 7 meter per second. So this is the value of V. Enters a magnetic field of magnitude 1.5 Weber per meter square. This is B. Sebab dia kata magnetic field. Calculate the magnetic force, F. And acceleration of the proton if it moves perpendicular to the field. Maksudnya, V is 90 degrees with B, 90 darjah. And question B, the proton move at an angle of 50 degrees with the field. Bermaksud angle di antara, let's say V ke sini, B ke sini, angle between them is 50 degrees. Given the mass of proton is 1.67 times 10 to the power of negative 27 kg. For question 8, to find the magnetic force, F equal to QBB sin theta. Substitute Q, which is the magnitude of proton, 1.6 times 10 to the power of negative 19. V is 3 times 10 to the power of 7. B is 1.5. And then sin theta is 90 degrees. Then you will get the answer as 7.2 times 10 to the power of negative 12 Newton. Okay, so kalau kita dah ada force, macam mana nak cari dia punya acceleration? Then you can use the equation F equal to ma. So A equal to F over m. And then substitute the value of magnetic force, substitute the value mass of the proton, then you get the acceleration 4.31 times 10 to the power of 15 meter per second square. What about question B? We are going to use the same equation. It's just that the angle is not 90 degrees. The angle will be 50 degrees. So use the same equation. Substitute the value of Q, 1.6 times 10 to the power of negative 19. V, 3 times 10 to the power of 7 meter per second. B is 1.5 Tesla. And then sin 50 degrees, you will get 5.52 times 10 to the power of negative 12 Newton. For acceleration, we can use the equation F equal to ma. Then the acceleration that we will get is 3.3 times 10 to the power of 15 meter per second square. Example 6.4. A proton, positive charge, moves at 7 times 10 to the power of 6 meter per second along the positive x-axis. So you can sketch an xy axis, or maybe we need z axis also. So proton moves along the positive x-axis, bermaksud this is the direction of V. It enters a region where there is a magnetic field with magnitude of 3 Tesla directed at an angle 50 degrees with the x-axis and lying in the XY plane. Bermaksud dekat kawasan XY plane ni, the angle of B is 50 degrees with x-axis. ini adalah B. So with the aid of diagram, show the direction of magnetic force on the proton. So you kena sketch a diagram, okay, macam ini. Okay, X, Y, Z axis. So you can use your hand rule method to determine the direction of F. So V ke kanan, B ke atas with angle of 50 degrees with V, and then where will be the direction of F? Question B, determine the magnitude of initial force that exert on the proton. So we can use the equation F equal to QVB sin theta. C, calculate the initial acceleration of the proton. So we can use the equation F equal to ma. And then for question D, if we replace the proton with electron, determine the magnitude and direction of the magnetic force that exert on the electron. So the answer for question A, the direction of magnetic force will be directed on the positive Z axis. Okay, so you can check with your answer. Make sure that you understand the position of V, B, choose your method, and then determine the direction of F. For question B, we use the equation F equal to QVB sin theta. Substitute the value of Q. Q is 1.6 times 10 to the power of negative 19. V is 7 times 10 to the power of 6. B is 3 Tesla. And then the angle between B and V is 50 degrees. So from this equation, we will get 2.57 times 10 to the power of negative 12 Newton. For question C, to find the acceleration, we use the equation F equal to ma. Then you will get 1.54 times 10 to the power of 15 meter per second square. And for question D, when we replace proton with electron, maybe you think that we need to put negative sign into this equation. But actually no. Okay, sebab force ni dia adalah vector quantity. So bila equation yang melibatkan vector quantity, you don't have to substitute the sign into the equation. So you will get the same value with proton. Cuma arah dia akan berbeza, or arah dia akan bertentangan. Okay, bila kita gantikan proton dengan electron, the force will be the same, but the direction will be opposite. Kalau tadi dekat positive Z axis, bila kita try to use hand rule, we will get the direction of magnetic force will be on this negative Z axis.